Hello guys, so in this video we're going to go over how to solve a problem that is in the mean value theorem. So basically the idea is that there's this theorem called the mean value theorem, where if we're gonna apply a series of steps to solve for a number c, and if the number c falls in between the range a to b, then it satisfies the mean value theorem. So without further ado, the first thing we do is we need to identify A and B, because we have a formula here that requires us to know B, A, f of B, and f of A. So our A is equal to whatever is the first term in our interval. So in this case, it's 0. And our B is whatever our interval closes. So in this case, it's 4. And keep in mind that they match with these right here. So when you're given an interval, the beginning bound is A, the closing bound is B. So in this case, our B would be equal to 4. So now, keep in mind we have a function over here. So the next step is we're going to identify f of A and f of B. And we do this simply by plugging in our value A into the function and B into the function. So we're going to go ahead and do that. So our f of A is equal to f of 0. And we plug in 0 everywhere we see x. So negative 0 cubed plus 4 0 squared minus 3. And for our f of B, we do the same thing, except we're plugging in our B, which is 4. So f of B is equal to f of 0 is equal to f of 4. And this time, instead of plugging in 0, we're plugging in 4. So everywhere we see x, we're going to plug in our B term, which is 4. So negative parentheses 4 cubed plus 4 x squared, which is our B, which is 4, minus 3. And whenever we do this arithmetic for the first term, this zeroes out, and we're left with f of A is equal to negative 3. And for the bottom, now keep in mind I put parentheses for a reason, because a lot of people do get this wrong. Use parentheses. So this is just applying simple PEMDAS, right? So PEMDAS is just basically the order of operations that you learned in Cal 1, or in Algebra 1, sorry, in pre-algebra probably. So basically the idea is we cube this and then we apply the minus sign. So 64 cubed, so because 4 cubed is 64, but then minus because we have a minus sign, plus 4 times 4 squared, so it's 4 times 16 minus 3. And we know 16 times 4 is equal to 64 positive. And then negative 64 is equal to 64 negative. So these cancel each other out, and we're left with f of B is also equal to negative 3. So I'm just going to draw a line to separate the two. F of A is equal to negative 3. F of B is equal to negative 3 as well. So now the next step is to take the derivative of f of x. So this is our f of x. So the next step would be to find f prime by taking derivative of f of x. So this one we're just simply taking the derivative of a function. So f prime of x would be equal to the derivative of this right here. So negative 3x cubed would be negative 3x squared plus 4x squared. The derivative of that would be plus 8x minus 3. So the derivative of negative 3 is 0. So now we have our f prime of x, we have f of b, which is right here, we have f of a, which is right here, we have our b, and we have our a. So the next step would be to plug this all into the formula for the mean value theorem, which is what I'm going to do right here. So we're going to plug in our f of b, which was -3. So we're plugging in the formula into right here. So -3 minus f of a was also -3. -3 divided by b minus a. Our b was 4 and our a was 0. So 4 minus 0 is equal to f prime of x. So our f prime of x, we solved for it, which was f prime of x is equal to -3x squared plus 8x. So minus 3x squared plus 8x. So that's our f prime of x. So all we simply do now is we're actually just going to go ahead and we're going to solve for x. So that's what we're going to do. So the top, so on the right hand side, minus 3x minus -3x, this zeroes out. So we have minus 3x squared plus 8x is equal to 0. So we're going to go ahead and simply just solve for x. So we're going to do this by just doing basic arithmetic. So 8x is equal to 3x squared. I moved this term over here and I changed the sign. We can cancel out an x and we're left with 8 is equal to 3x and x is equal to 8 over 3, which is our number c. So we call this c. So this x that we solve for is equal to c. So the next step is, does c fall between a and b? And what's our a? Our a is equal to 0 and our b is equal to 4. 8 over 3 is approximately 2.66. 2.667 if we want to round it, which does fall. So since it does satisfy, since c does fall between a and b, then the mean value theorem is satisfied. So the mean value theorem is satisfied because we identified our c to be 8 over 3 or 2.667. So the mean value, so we're basically testing to see if the mean value theorem is satisfied. So we're going to do this problem again in retrospect, or we're just going to simply go over what we did. So the first thing we did is we simply identified a and b, which are our interval bounds, which is 0 and 4. Next, we plug in a and b into our function f of x, which we did to identify f of a and f of b. And we got -3 as well as -3 for both cases. So the next step is we took the derivative of f of x to find f prime of x, which we got right here. Then the next step, which was right here, which I forgot to write, but we solve for x. And in doing that, we got x is equal to 8 over 3, and we call it our number c, right? And then we ask ourselves, does c fall between a and b? And a is 0, b is 4, c is 2.667 if we turn this into a decimal, and it does. So since c is greater than a but less than b, then the mean value theorem is satisfied. So that's basically the idea. So we're testing to see if our number c falls in between the interval a to b, and if it does, mean value theorem is satisfied. And that's how you do and that's how you use the mean value theorem. Thank you guys for watching. I hope this was helpful. Hello guys. So In this video, we're going to go over how to apply the mean value theorem. So basically, using the formula, the fundamental idea is that we're given a function over an interval from a to b, and we want to see if it satisfies the mean value theorem. So without further ado, the first step of this would be to be able to identify what your function is, what are your interval bounds. So we have to be able to identify a and b. So our a is whatever is inside our x interval, the first term, so that would be 3, and our b is whatever is the second term, so in this case it would be 6. Now that we have that, the next step is to be able to identify f of a and f of b. And we do this simply by just literally just plugging in a into this formula, into this function, and then plug in b into this function. So we're going to do that down here. So f of a, that's an f. F of a is equal to f of, what's our a? Our a is 3. F of 3, and then everywhere we see x, we plug in 3. So negative 3 squared plus 8, 3 minus 17. And then we do the same thing when we're trying to find f of b. So f of b is equal to f of 6. And then everywhere we see x, we plug in 6. So 6 squared plus 8 times 6 minus 17. And then we just perform arithmetic to solve this. So 24 minus 17 is 7. 7 plus 9, but we have a minus sign in front of it, so 7 minus 9 actually comes out to be negative 2. Or, yes, that's correct. Minus 9 plus 7. So this comes out to be negative 2. And down here we perform arithmetic. So we have 48 minus 17. 48 minus 17. And right here we have 36, but since we have a minus sign in front of it, this would be minus 36 plus 48 minus 17. So this comes out to be 12. 12 minus 17 is negative 5. So we have identified our f of b and our f of a. So our f of a is equal to negative 2, as we solved over here, plugging in our a term, so negative 2. And our f of b is equal to negative 5. So now we have a, b, f of a, and f of b. So the next step would be to actually take the derivative. So we are going to find f prime of x. So we are solving for f prime of x by taking the derivative of f of x. So f prime of x, just applying the regular old derivative properties, f prime of x is equal to negative 2x plus 8. And now the next step would be to set f prime of x, set f prime of x equal to, that's a prime right there, equal to f of b minus f of a over b minus a. So our f prime of x would be negative 2x plus 8, and we set this equal to f of b, which was minus 5, minus f of a, which would be -2, over b minus a. So 6 minus 3. And when we compute this, and then the next step would be to, once we set it up, the next thing we would do would be to solve for x. Solve for x. And in solving for x, what would this be? This would be 5 minus -5 plus 2, which is -3, over +3. So this is equal to -1. So we have 2x plus 8 is equal to -1. We subtract 8 from both sides. We get -2x is equal to -9. And then we apply algebra. So x comes out to be 9 over 2. So this is our c, it means the exact same thing is 9 over 2. And since our c, 9 over 2 is a fraction that is equal to 4.5. So 9 over 2 is equal to 4.5. And since our c falls within the bounds of a and b, it satisfies the mean value theorem. So I'm going to go ahead and write it on the board since I ran out of space. So since c falls within a and b, so since c is basically, since c is greater than a but less than b, so it falls within the bounds, then the mean value theorem is satisfied. So that's the idea behind this. The idea is, so we're going to take this back in retrospect. The first thing we do is we identify a and b. So a is 3, b is 6. We know that because we just look at their interval. We just look at the what is our interval. So that's our a and b. The next step would be to identify f of a and f of b. So we do that by plugging in a and b respectively into the f of x, not f prime of x, f of x. So we were able to do that, and we got our f of b to be -5 and f of a to be -2. The next step was to take the derivative. So we took the derivative of f of x, and we got -2x plus 8. And then the key step is plugging it into the formula. So f prime of x, we set that equal to f of b minus f of a divided by b minus a. And over here, we performed the arithmetic to solve for x, and our x came out to be 9 over 2. And 9 over 2 falls within the interval of 3 and 6. That actually falls right in the middle. And since a and b, since a is less than c, since c falls within that range, then the mean value theorem is satisfied. And that's how you use the mean value theorem. So solve for c, following that step by step. And if c falls within the bounds of a and b, then it satisfies the mean value theorem. That's all. Thank you guys for watching. I hope that was helpful.